Welcome to Beyond the Grid. I'm Beth Rattner. I'm your host. Today is really the first of our podcast series. We're going to be doing a bit of a deep dive into the people behind the next generation of the grid, whatever that may mean. There's all sorts of definitions that we can talk about in this series. We're going to start today by thinking about data centers, infrastructure, the electrical grid that's beyond all of it. And so we're going to start today with Chris Ellis, who I'm going to let him introduce himself. Hi, Chris.
Hello.
Chris, tell us your title. Tell us a little bit about yourself, how you got here, and just to load up the questions right out of the gate, your first experience with electricity in general.
Yeah, sure. Well, first, thanks so much for having me. I'm Chris Ellis, CEO of Edge Infrastructure. We're an Endeavour company, and our goal is to develop products that improve the efficiency, sustainability, and performance, mainly of data centers, but oftentimes these products are beneficial outside of data centers. Your question was my first?
Yeah, your first experience with electricity. Like, you must have been a kid.
So when I was in fifth grade, there was a science fair, and I figured out how to put pins on a board on the left side and on the right side, and I put questions on the left side, and I put answers on the right side, and there's a piece of wire with two ends, and if the person touched the question to the right answer, a light bulb would come on.
Do you go on and study electrical engineering?
I did not. I joined the Marine Corps, and I did electric generation and distribution in the military. And so I set up essentially what we didn't call them back then, but they're essentially microgrids made up of on-site generation that were quickly deployable, modular, and then took that into a career with Caterpillar. And then when I left Caterpillar, I was helping a company called PowerSecure get into the microgrid business, using the on-site generation that typically was a liability and only for resiliency. They saw opportunity to use that on-site energy to participate in utility programs to assist the utility with capacity and distribution problems and monetize it. But the generators weren't your typical generator. They had to have the controls to be able to connect to the grid and share energy with the grid. So I was helping them with that, and eventually went and joined their team. I think there was about 10 of us at the time. And somehow, thankfully, we grew it into the largest microgrid company in North America, had 85% share of the microgrids by about 2015.
So you've had this orientation around microgrids for a long time. Well, that kind of leads me to my first question, which is, it feels like historically whenever there's a new round of technology, whether that's renewables or EVs or IoT, Internet of Things, 5G, like everyone's like, oh, the grid's going to crash. This is it. And certainly with AI, we hear this all the time. Maybe just give us a little perspective from your microgrid history to what you've been seeing. Like, how would you explain those risks?
Whether it's AI or just in general, we all have a phone in our pocket. The energy you're using from your battery is not the only power you're using when you're using your phone. You're operating servers somewhere in the world that are processing that data to get you what you want to see. And with AI, they're processing a lot more data to get the answers that you want. But ultimately, what that means to the grid is just more demand. And we were moving down the road of shifting to renewables, which already, if not done correctly, puts the grid at risk. If, for example, in the Southwest, they have a lot of solar panels. Makes sense, there's a lot of sun in the Southwest. But also what that means is that's capacity on the grid. So with sun shining, all your panels are going, you have capacity on the grid, feeding load. If a cloud comes over or the sun sets, that capacity goes away. It would be as if you had 100 generators on the grid, and some of them would just shut off from time to time. Mm-hmm. And that capacity would go away. Well, the load didn't go away, the capacity went away. So whether it's windmills blowing or not blowing, the sun shining or not shining on solar panels, the grid has to be able to be supported if that goes away. And what that means is you have to have some kind of what we call spinning reserve. So if I've got a megawatt of solar and my grid is needing that megawatt of solar, I have to have a megawatt of capacity somewhere available and running idle. That's likely emitting emissions in the air. I think the key here is distributed generation, where you have generation located at various customer sites that are high off-takers of energy, and you put them on their on-site generation during these peak times. And someone might say, well, you don't want to start all these diesel and natural gas generators for that.
Right,
But the truth is, and we've done studies on this, the emissions footprint of even a diesel generator operating for a load management program with a utility company, or there's various ways, is much cleaner than the footprint of the utility at that time, because the more demand there is on the utility, the more capacity units are online, the dirtier the power is. Data centers are seen as the problem right now. They're seen as the entity that's creating this problem. They don't have to be seen that way. They can be seen as the entity that's bringing the solution. And the way they would achieve that, one thing about data centers, 95% of them, they have on-site generation in case of a power outage, and that can back up the entire facility. Well, if you use that on-site generation during these peak times to provide relief for the utility, this requires the utility to allow this. And this is true in many cases. In many areas of the country, the utility has programs where they incentivize customers to get off the grid during peak times. And there's different reasons: capacity constraints, transmission constraints, cost, frequency stabilization, et cetera. If these data centers, and we do this at Endeavour in our Edge Data Center group, would install the right system, they could participate in these programs. And instead of being the problem at the peak time that I talked about earlier, they can get off the grid during that peak time. And if we get those peaks down, we open the door for more capacity on the grid for other folks. What that requires some changes in the data center. One of them is most data centers are backed up by what we call Tier 2 generators. The tiers are the ratings the EPA put out to restrict the emissions on diesel engines. And Tier 2 is pretty dirty. The cleanest diesel engine right now is Tier 4 final, which is about a fourth of the emissions, a third of the emissions of Tier 2. Less than that in many cases. In order for you to use your on-site generation for something other than emergency, which would be what we're talking about here, you're using it to participate in these grid programs to help the grid, you have to have the latest EPA technology, meaning you have to have Tier 4 final generators. Most all data centers are putting in Tier 2 generators. Number two, you need a control system that allows you to do this transition from the grid to your on-site generator seamlessly that doesn't affect your operation. We have to have confidence in that operation. Data centers don't like switching from generators to utility without a lot of reassurance. But with those two changes, which aren't very expensive and really aren't that significant, the landscape of data centers and their relationship and their perception to their effect on the utility grid could shift 180 degrees.
You seem so calm and confident about all this, Chris, and yet it feels like like when we look at the press, it feels like a very misunderstood point.
Well, it's awareness, it's prioritization, and it's oftentimes money. We're passionate at Endeavour at not only finding new technologies, but finding where the technology and the economics intersect, so that you're changing the landscape of tech by providing more sustainable, more efficient equipment and doing it cheaper or at par with traditional.
That leads me to sort of my last question here, which is, it's 10 years from now, it's 15 years from now, pick the time horizon that you think is best. We're going to look back on this moment and say, we got that right. That was such a smart thing that we did at that moment.
To me, when I focus, my passion behind all of this, I'm thinking of people. I start with people, and then you work back from there. I mean, there's another angle where I see folks that are passionate about the environment to the point that they demonize people. People are the problem. And I don't think that gets us anywhere. But I think our heart has to be for the people. And I think that's what changes behavior. I think we can find some common ground there. Unfortunately, I hear a lot of debate over whether CO2 is the problem. It's a great debate, but I know that people are breathing things they shouldn't be breathing because of, fossil fuels, and anything we can do to reduce that helps. And that's a big passion of Endeavour. Our founder, Jake Carnemark, his big passion is all these technologies ending up in these marginalized areas, providing energy and drinking water to folks that would otherwise not have it. Being able to plug their phone in, charge their batteries, have a light, cook their food, from a clean energy source.
I love that you're like, let's put our hearts first. Let's help each other first. And then of course, getting poisons out of the air, water and soil are going to follow from that. Thanks for being our inaugural guest. You did a great job. And is there anything else actually that you want us to know before you?
No, I appreciate you having me, and look forward to talking again.
Thank you, Chris.